Hello, and welcome to Triangle Congruence Theorems, Day 2. First, I want to remind y'all about isosceles triangles. Isosceles triangles are very special because they have two congruent sides and two congruent angles attached to the base. Alright, let's say this is the base here. CB has two angles attached to it with the same measurements. They're congruent, as you can see with that one arch, and two sides that are marked with ticks that are congruent. I'd also like to tell you about the reflexive property today. This happens when a segment or angle is congruent to itself. This always happens when triangles share angles or sides. For example, in this triangle and this triangle, they both share side AB. Same thing happens with these two triangles. They share side CD. It's going to look kind of funky in our proofs, but it's okay. And then, of course, we also have these two triangles. They overlap on the bottom in side EF. So let's do some proofs that will use isosceles triangles and the reflexive property. All right. In number 1, the first thing that I want to see is triangle WIM congruent to triangle LIM? Alright, what's given to us? Well, first, we are given these singular angles and these double angles. Two things is just not enough to state that triangles are congruent. However, we just learned about the reflexive property. These two triangles share a side. Now we suddenly have angle, side, angle. So we do have congruent triangles. Let's write out the proof. Let's begin with that top angle. That's angle WIM. That's congruent to angle LIM. And this was a given angle. In the middle, we have the side that they share. And this is that funky part. Its side IM is congruent to side IM. They both have it. This is the reflexive property. Next, we have those double angles. I got angle IMW congruent to angle IML, and this was a given angle. Well, in the end, triangle WIM and triangle LIM are congruent because of angle, side, angle. Let's try another. Number 2. Okay, are these two triangles congruent? Well, we have single sides, we have an arch of an angle, and they share a side in here. So this is actually congruent by side, angle, side. Let's begin with a single tick mark. I should have made this a double. There we go. All right, so we have side FG congruent to side HG, and this was a given side. Next, we have the angle FGL congruent to angle HGL, and this was a given angle. And lastly, we have that side that they share. GL is congruent to GL by the reflexive, that's how you spell reflexive property. Alright, so I can say that triangle FGL is congruent to triangle HGL by side, angle, side. Number 3. Let's see. Are these two triangles congruent? They both share this side. They both share an angle, or they both have an angle. And then they both have this side. Oh, dang it. You know what we have here? We have an ASS. So these are not congruent. We're not going to fill out 4, but let's write some congruency statements. Well, they both have side JK marked with 1 tick and ML marked with 1 tick, and that was given to us. We also had the two angles, angle JMK and angle LKM. That was given to us. And we also know that they both share the side KM. And we know that because of the reflexive property. Number 4. Now, this might look funky to you because I have numbers here instead of just tick marks. But that's fine. Let's label. Each of the triangles has a single tick mark, or they both have 3-inch sides. I drew the tick mark. They both have a 5-inch side, and they share the middle. These are congruent by side, side, side. Now, that middle line, I'm going to ask in class if anyone knows. This is a very famous triple. That middle line would actually have a measurement of 4. 3, 4, 5 is called a Pythagorean triple. Anyways, let's write down what we've got. We have the 3-inch sides. RA congruent to RY. We were also given that AM is congruent to YM. Again, a given side. And then the reflexive property allowed us to say that MR is congruent to MR. So we can finally end it with triangle MAR is congruent to triangle MYR by side, side, side. Gorgeous. Onwards we go. We only have a few more to do. Ooh, okay. We have triangle WIM congruent to LIM. Maybe. Let's see if they actually are. What are we given? We are given that WIM is congruent to LIM. Let's mark that. WIM is here, and LIM is also there. Okay. We also know that WIM and LIM are isosceles triangles with base WM and ML. Okay. This is a base, and so is this. All right, great. Now, what do we know about isosceles triangles? Each isosceles triangle has two congruent bases attached, congruent angles attached to their base. I almost said bases attached to their angles. That's silly. So if we look at the left triangle, this angle and this angle would be congruent to each other. Now, because the right triangle has the same measurement up top, its base angles are also congruent. And they share one last thing, and that's the side in the middle. It looks like these two triangles are congruent by angle, side angle. All right, let's write it down. First, we were given WIM is congruent to LIM. So this was a given angle. Then I can say that angle IMW, that's not a W, is congruent to IML because of isosceles. Oh, that is how you spell isosceles. Nope, missing a C. Isosceles triangle. And then finally, I can say that IM is congruent to IM because of the reflexive property. So I can conclude that triangle WIM is congruent to triangle LIM by angle, side, whoops. Oh no, I did the right color. Never mind. Angle. Number 6. Is MAR congruent to MYR? Well, let's see. Each of them have a single arch. They each have a single tick. And they share the middle side. Oh no, we've got another ASS. Well, let's write its congruencies. Okay. We've got angle AMR congruent to angle YMR. That was given. We have AR congruent to YR. That was given to us. And then we can say that MR is congruent to MR by the reflexive property. Oh, another MAR, MYR. Let's see if these are congruent. Okay, so they each have 5-inch sides. I'll label them with a tick because I prefer that. They each have an angle. And they seem to share this middle side. Fantastic. We've got a side angle side. So, we've got a M congruent to YM. And that was given. We have the two angles, AMR and YMR. And then finally we have that middle side, MR, that's congruent to MR because of the reflexive property. So triangle MAR is in fact congruent to triangle MYR by side, angle, side. Is triangle GEO congruent to ORG? They each have a 5 centimeter side. They each have a 12 centimeter side. And they share the middle. Hooray! We're congruent. Best side, side, side. Here we go. We've got EG congruent to RO. We have EO congruent to RG. And then we have GO congruent to GO because of the reflexive property. So we can conclude that triangle GEO is congruent to ORG by side, or side, side. All right, last one. Ooh, another isosceles. Okay, let's see if SET is congruent to SNT. We have that EST is congruent to NST. Ugh. Let's try drawing that again. NST. And then I want to still make that. There we go. And SET and SNT are isosceles triangles. And these are the bases ET and TN. Okay, well, what do we know about bases? Just like before, we know that the bases have two congruent angles. But let's use the other property, because we use the two congruent angles here. Let's use the fact that they have two congruent sides. Well, that means this side and this side are congruent. And in the triangle on the right, these two are congruent. Check that out. We have side angle side. Honestly, this is my preferred method versus number 5. 5? Yeah. But you know what? They both work. We've got side angle side. Let's do it. Okay, let's start with the given angle, because it's given. EST and NST. Given angle. And then we've got the two sides. We've got E. No, that's green. I used blue. Blue. ES congruent to NS because of isosceles triangle. What's the properties of isosceles triangles? We can't fit that in the box. And of course we have TS congruent to TS because of the reflexive. So we can in fact conclude that triangle SET is congruent to SNT because of side angle side. Just like the previous triangle congruencies, the best way to get this is by practice. So that's what we're going to do. If you have any questions though about isosceles triangles or the reflexive property, please let me know, or whoever else is helping you know. Anyways, have a wonderful rest of whatever day it is for you. Bye!